So the last time we have been talking about database management systems, which is a system that essentially manages the data, all the data in that you are interested in, and then different applications can access the data by a unified interface. Here you see the high-level architecture that we have discussed. The last time I gave you a quick overview. In the coming lectures, we're gonna look at different components within that architecture, and we're gonna discuss in more detail what is behind that. Now, in this lecture and also in the following lectures, we'll be looking at the interface to the database system. So that is essentially the interface that either you as users are directly using or that the applications are using. If you want to read up on more details beyond what we will be discussing in the course, or if you just want to see an alternative explanation of the same content, then you can have a look into the course book. Here on the left lower corner, you see the reference to the chapters that are relevant for the material that we will be discussing in this lecture and in the following lecture. RG, that stands for Ramakrishnan and Gerke, and the relevant sections, it's primarily section 3 and section 5. The question last time was whether you actually need the book, and you don't need the book if you understand everything that I point out here in the course. So for the homeworks, the relevant material is what we are covering in the course. But if you want additional information, then it might make sense to have a look at the book. All right. So now we are talking about the database interface surrounded with the red circle there. And typically database management systems support a language called SQL, that's the structured query language. This is what you essentially use in order to issue commands to the database management system, telling it to either retrieve data or to change data in some way. It's a very old standard already. I mean, the first version of it appeared in the 70s, and currently the latest version has a couple of hundred pages. So we're not gonna cover all of SQL. It's a very powerful language, but we're gonna see a subset of features which are sufficient for most use cases. Now, people distinguish different types of SQL commands depending on what they do. First of all, you have the so-called DDL data definition language. And that one essentially allows you to define what the structure of your database looks like. So you can essentially tell the database management system what kind of data entries are admissible. You can set constraints, and then the database management system will reject any changes to the data that would not comply with those constraints. Then, beyond defining constraints, of course, you can also insert and manipulate and retrieve data. That is the DML, the data manipulation language. We will also have the transaction control language. That one is discussed a little bit later, which allows you to group SQL commands into so-called transactions, which have several nice properties that we'll discuss later. Also, you have a couple of commands in order to assign data access rights, for instance, which are controlled by the database system, but that we won't go into detail in this course. All right. Now, in the following, we will first of all discuss about the data definition language. After that, we cover the data manipulation language. The TCL is covered a couple of lectures later, not immediately. So let's start with the data definition language. You are defining a so-called database schema, which essentially describes the content that you can insert into your database. Now, we have heard last time that those relational databases that we are focusing on here, they consist of a collection of relations, where each relation essentially looks like a two-dimensional table, essentially a little bit like a spreadsheet. And one first thing that you can define for each relation is what are its columns, what are the names of the columns, and what are the data types of the columns. Because each column of a relation is associated with a data type. And once you insert data entries into that relation, they actually have to comply with those data types. We're going to see some concrete examples for that later. You can generally introduce more constraints beyond the data type. You can put constraints on single relations. You can also define constraints that link multiple relations. We're gonna see some specific examples for constraints in the following slides. Now, in order to create one relation, this is the command that you use in SQL. In SQL, we are actually not talking about relations, but we're talking about tables. So strictly speaking, there's a couple of fine differences between relations in the relational data model and tables in the SQL language. But for the moment, I'm not going to go in detail here. You can assume that what is called table in SQL is meant to represent what I called relation in the context of the relational data model. And this is the command for creating one of those tables. Create table, then you write the name of the table, and then between parentheses, you have a comma-separated list of column definitions, where each of those column definitions consists of the column name and the column data type. Now, let's make things a little bit more concrete. So in the following, we are going to use a very simple university database with information about students as a running example. So first of all, it might make sense to introduce a table in order to store information on students. And we can do this with the command that you see here. I'm telling the database system, I want to create a table named students, which has an SID, a student ID of type integer, then an S name, student name of type text, and the GPA of type real. All right, and maybe also want to keep track of which courses those students are enrolled in. So I might want to introduce a table enrollment, which essentially links student IDs to course IDs. So the content of this table that you see in the middle, enrollment, would be pairs of student IDs and course IDs with the semantics that the corresponding student is enrolled in the corresponding course. And maybe the course ID alone, that's not very informative. So ideally, we also want something which links the course ID to the course name. So we can introduce one more table which is doing this, which has the course ID and the corresponding course name as columns. All right, so that is a very simple database with 3 tables, and you can create that relatively quickly with SQL commands. Now, beyond specifying that certain columns have certain data types, perhaps we want a couple of other constraints. Is there any kind of constraints on that database that anyone can think of? Constraints that essentially ensure that the database content will make sense. So if you have an idea for a constraint, please write it into the chat. All right, and here comes already like the, okay, very good, very good. Okay, there's a couple of very nice propositions here, thank you. Okay, and please feel free to still type something if you have another idea. Right, so there's a couple of propositions about restricting, for instance, the value range for the GPA, and that makes a lot of sense because right now it could be any kind of real number. So restricting the value domain further by, for instance, setting a non-negativity constraint, that is good. And the other thing that I see here in different variations, there's many very good ideas here, thank you, that's amazing, is to enforce some kind of uniqueness constraints. For instance, we have all those IDs in our database. And typically in order to make sense, an ID should be unique. So you shouldn't have, for instance, 2 students with the same net ID, because that would create all kinds of confusion. So the proposition here is to add some constraints which enforce a uniqueness in certain columns when it comes to the IDs, for instance. And another good proposition is, for instance, that if you look at the enrollment table, the enrollment table links students to courses. So what we want is that the student and the course that are linked, that they actually exist, and that a corresponding entry has been inserted into the corresponding other table. So you don't want to store enrollments for a student for which you don't have the name entered, and you don't want to store an enrollment for a course that doesn't exist in your database. So it makes a lot of sense to link those different tables together. So very good propositions. And this essentially covers already the things that we will see in a little bit more detail in the following. So very good. Now, general term here is so-called integrity constraints. They generally limit the content that you can insert into the database. And the database system takes care of enforcing those constraints. So if you try to change the data in a way that violates one of those constraints, then typically the database system will tell you to that the update cannot be done, or what we will see later, there's also a possibility that the database system essentially tries to fix things itself, but in the most typical case, it would just essentially tell you, no, this update is rejected because it violates one of those constraints. All right, there's different ways of adding those constraints to the table schema that we have defined before. In general, in SQL, there's always many, many different ways of expressing the same thing. So if you are using SQL over a while, then you will learn about different variants, and you will typically figure out what variant of the commands you prefer. So in the following, we're going to see one way of writing those constraints, for instance, but just so you know, there's many different ways of writing the same thing. All right, so we can add constraints, for instance, by using the alter table command. And this first type of constraint that we will be looking at, those are the primary key constraints. And I have already seen somewhere here in the chat the keyword, the catchword primary key, so very good. That essentially is a constraint by which you say that one column or a combination of columns corresponds to an ID, a unique identifier. So those primary key constraints are placed on single tables, and they identify a subset of columns generally that are key columns. And the semantics is that no two entries in the same table can have exactly the same value combination in those key columns. So that means that if you fix the values in the key columns, then you automatically narrowed it down to one single node. Like for the students, if you have the net ID, you narrow it down to one specific student, because no two students can have the same net ID. So this is the general syntax of the command. We write alter table, then the table name, add constraint, makes sense. And then here we want to add a primary key constraint. So here between the parentheses, you have a comma separated list of the columns that you want to become the key. So those columns must exist in the table that you're altering. For instance, here, you're altering the students table by adding the constraint that the student ID should be a key. So it should be unique, and you must have a value entered there. Also, for the enrollment, it is a little bit more difficult, because for the enrollment, the same student could be enrolled in two different courses. So then would have two entries in the enrollment table with the same student ID. Also, for the same course, you typically have many students that are enrolled in the same course, which would be represented as multiple entries in the enrollment table with the same course ID. So in separation, we cannot say that either the student ID or the course ID forms a key for the enrollment table. So what we do instead is that we take the combination of the two. So we say that the student is not unique, but the course is not unique, but a combination of a student and a course should be unique, because otherwise you would be storing enrollment information twice. That seems redundant and unnecessary. That might change, by the way, if we add, for instance, a year column in the enrollment. If we say that we don't keep track of the current state, but also of the state in past years, then it might make sense. Somebody is taking the same course twice, then you would have to extend it. But for this very simple database, we can say that a combination of the student and the course is unique. Finally, with regards to the courses table, we have said that the course ID should be unique, and this is the constraint in order to express that. Now, a different type of constraint is the foreign key constraint. This one links together two tables, and in one of those tables, it identifies a set of foreign key columns. And then it links those foreign key columns to the primary columns in another table. The semantics is that you are essentially stating that any value combination that appears in the foreign key columns must also appear in the primary key columns, because you are essentially linking each entry in the table with the foreign key to one entry in the table with the primary key. So if we fix the values in the foreign key columns, then that should narrow it down to one single row, to one single associated row in the table with the primary key constraint. All right, let's make it more concrete. So here you see the syntax for the command by which I add foreign key constraints. We are altering a table again, and we add a constraint of type foreign key, where we specify the foreign key columns between those parentheses. And then we reference another table and the corresponding columns in that other table. Depending on the database system, sometimes there's additional restrictions about what type of foreign key constraints you can define. And the syntax might always vary between different database systems a little bit, but this is the command that should work in the Postgres database system. All right, so here we are extending our running example database. And we already had that in the chat. People suggested that there should be a link from the enrollment table to the students table and also to the course table. Now here we are taking care of the link to the students table. We're linking the student ID column in the enrollment table to the primary key student ID column in the students table. Right? And so if you try to insert an enrollment for a student that hasn't been entered, then for instance, the database system would give you an error. Same principle for the courses. Here we are adding a link between the course ID column in enrollment to the primary key constraint in the courses table, right? And here we essentially ensure that you're not inserting any enrollments for courses that don't exist. All right. Okay. All right. So, and now I'm going to give you a little exercise which links to the example that we have just seen, just to get the hang of it a little bit. While you're working on the exercise, I will also look for questions in the chat. And The exercise is the following. So we are considering a bookseller, let's call it Zamona, who wants to start selling books via a web portal. So your goal for the moment is to create a database, a schema for a Zamona in order to store information on books. So each of those books has a unique integer ID and a book name. You also have writers on the other side, which have unique names. And those writers are linked to books as authors. So your goal is to come up with the commands to define a database with 3 tables for this scenario. And you can either do it just by writing down the command, or if you have already Postgres installed, then you can try it out yourself. I will very quickly demonstrate to you what that looks like using Postgres for once. Let me quickly share my console here. All right. So at this point, you should be seeing the console window. If that is not the case, please let me know in the chat. Here are some first questions on the example. Yes, there can be more than one writer for a single book, and one book can also be written by multiple authors. Very good questions. Okay. Right. So now I'm quickly gonna demonstrate how using Postgres looks like. Maybe some of you have already experience with Postgres, so you can skip that and already start working on the example. For the others, it might be interesting to have a look. And after that, I'm gonna give you a few minutes to try coming up with a solution for the example. All right. Okay. So first of all, there's many different ways of accessing Postgres. There's different interfaces, and it also depends a bit on which operation system and which version of Postgres you're using. The following, I'm going to use one of the most basic tools to access Postgres, which is the SQL tool. Now, before I'm accessing a database, I first of all have to create it. So in this example that we have seen before, we have been talking about students and courses. So this should be a university database. So I'm entering the command create DB, create database, and what should we call it? University, for instance. All right, so now the database has been created, but right now it's not populated yet. So now I'm gonna log into that database with PSQL. All right, and now we are in the database and can issue SQL commands. Now, some of the, so you can try out the example that we have seen. I'm not gonna do the entire example, just a few commands just to see what it looks like using Postgres. For instance, we have created a table about students. So what we can do here, we can create a table with the student ID and the student name, right? And if we do that, then the database tells us it has successfully created this table. And we can also create the table enrollment, for instance, which has the student ID, and it also has the course ID. All right. So, all right. And okay, and so depending on your Postgres setup, you have to essentially, you have to make sure that you have installed it properly. Otherwise, you might see some some error messages here. You don't necessarily have to do the example with me here, so I'm just giving you a little glimpse of what using Postgres looks like to make sure they have seen the console at least once. And then you can try setting it up and maybe doing the course example or the exercise that we have now. You can try to do that with the database. One good question, how do you list all the tables? The command for that is \d in Postgres. And here you see all the tables that we have introduced so far. All right. So I'm gonna go back to that example later. What was the last table that we had? It had, yeah. All right, I can still add this one. Courses, the CID was of type int, and the course name was also of type text. All right, and here, and here, for instance, I'm adding one of those constraints. All right, and so I'm not gonna go through the entire example here, but this is the principle. You issue those SQL commands, for instance, in a console like this one here in the database system, gives you feedback about whether executing the command was successful or not. All right, so either with the terminal, if you have already installed it, or if you just write down the commands. I give you a couple of minutes in order to do this example here. Let me quickly share the slides again. And here they are. All right, here you have the slides. So I'm going to give you just a few more minutes in order to think about that and in order to try writing those commands. And if you have any questions in the meantime, then please ask them in the chat. Okay, and it seems that somewhere in the slides it says add constraint explicitly. That is a typo. It should just say add foreign key or add primary key. This is what we use in the examples. Okay, that's the exercise. So there is no exam in this course. Was one question about an exam, and there is no exam in this course. And for the homeworks, in general, the syntax should be, so basically whatever syntax works in Postgres. There's slightly different SQL dialects for different database systems. And for the homework submissions, please use the one that is supported by Postgres. In most cases, it doesn't matter. So SQL database systems, they implement the SQL standard quite tightly typically. But every once in a while, there is one detail which is a little bit different in different SQL versions supported by different database systems. So in case of doubt, I suggest to go with the Postgres syntax, which is also the syntax that we will see here in the slides. So the grading is based on homeworks. In general, there will be 7 homeworks and your best 6 submissions are counted. Also, those homeworks are to be done alone. So there's a couple of differences to this course in past semesters. First of all, there's no exams in this course, and also the homeworks are no group homework, but they are done alone. And here the question is, that is a great one, when we can directly set the primary key and foreign key, whether we can set them directly when creating tables. And yes, you absolutely can do this. If you use the primary key keyword in creating the table, for instance, then you can make a column directly the primary key. There's different ways of setting those constraints. Here we have seen how we can add them afterwards, but you can also add them directly when creating the corresponding table. Very good. All right. I think now you had a little bit of time to look into this. So we're gonna publish the complete solution on the website, but the high level idea here is that you essentially have again database with 3 tables. You have 1 table about the books, you have 1 table about the writers, and then you have 1 table linking the books to the writers. Like here you have this table in the middle, which links the students to the courses that they are enrolled in. And in a similar way, you can link the authors to the books that they have written. So it's the same principle as here, just with a different scenario. All right. Now, beyond just defining the schema of the database, of course, you can also insert data that complies with the schema. You can delete data, you can update it, and you can analyze it in various ways. And in the following, we're gonna see commands for doing all of those things. So now this is the data manipulation language. First of all, we want to insert data into our database. And here you see, first of all, the command for inserting one fully specified row into a table in a database. So here we have this insert into table name, values, and here you specify the values for different columns for one single row, right? Here I'm saying fully specified. One feature of SQL is that it allows you to essentially handle cases where some parts of your data are unknown. Let me quickly mute everyone. I can hear something in the background here. Right. So, okay. Everyone should be muted except for me. Okay. Good. All right. So here we first of all see a command for inserting a fully specified row, which means that you are specifying values for each of the columns, but you do not have to do that. SQL has a way of representing fields where you don't actually know the value currently. It is called an SQL null value. We will see this in more detail later, but here we already connected that a little bit because the second command that you see here, it allows you to specify values only for a subset of the columns, and the remaining columns, they will be filled up with null values automatically. So in the second case, you have to specify for which columns you actually want to set a value. All right. Now, what we can do here, first of all, we want to store information on some students. So it makes sense. We want to insert an entry for a student named Alice. And here you can see how we do this. We want to insert something into the students table with the values 3 for the student ID, Alice for the student name, and 4.0 for the GPA. All right, and as you see, the corresponding table, the row appears here on the left upper side. All right, now let's also insert a student named Bob, but this time we're only specifying values for the student ID and the student name. Perhaps we currently don't quite know the GPA when entering the data, that will be automatically replaced by this null value placeholder. Okay. So this is how you can insert data, but in practice, if you're using an SQL database system, then if you want to analyze data, you're typically loading it from a file, and Postgres also supports the commands for that. You can load the content of a table from a file by using the command that you see here, copy some table from some file specified as a path with specific delimiters and with a specific representation of null values, for instance. So it's many versions of this command, but it tends to be very useful in practice. All right. So here, for instance, we might be loading the information, all the courses from some comma-separated value file, which we could do by a command like the one that you see here. Okay. We can insert data. Of course, we can also delete data. You can delete rows from a table which satisfies certain conditions with the command that you see here, delete from table name where some condition holds. And that condition essentially specifies which rows in a table you want to delete. We will see in more detail later which syntax you can use for those conditions. SQL supports very rich conditions, but for instance, you could use some inequalities between columns and constants, and we will discuss all the different types of conditions that you can use here in more detail later. For instance, our course database, we might want to delete the 6320 course because that one is not given this semester. So if you here observe the original course table after the command, it will shrink by one row because we delete the one where the condition CNAME equals CS6320 is satisfied. Beyond inserting and deleting data, you can also update it. You can update the specific rows and like the values in specific columns or specific rows using the command that you see here. We are simply writing, we are updating a table, we are setting specific columns to specific values for all the rows where this condition here is satisfied. So this command changes those rows satisfying the condition by writing the given value into the given column. Right? So here, for instance, maybe we want to change the course ID to number 7, where the name is 4320. And here you can see the table changing after we run the corresponding command here. All right. All right. Now, this is an exercise that you can do at home, or I mean, at home anyway, but an exercise you can do after the lecture. For the moment, I can show you again how those examples work in Postgres, just to make sure that you have seen that once. Let me quickly share my screen again. Console. Right, and what did we insert here? For instance, okay, we inserted the student named Alice. Okay, and I think they actually didn't define the GPA column when I made the example before. Let me quickly verify that. So here with the \d command, you can show all the tables that are currently defined. So at least I defined the students table, but let's see which columns I have in that table specifically. And with the syntax here, a \d and then the name of a table, you can actually find the different columns of the table. And here indeed, I made a mistake because I didn't, or I mean, it is inconsistent with the example slightly because I didn't introduce the GPA column. So what I can do in those cases is that I delete the students table again with this command. So now I only have 2 tables left. And now I'm creating the students table again. What did we have? We had the student ID, we have the student name, and we have the GPA. There's different versions that I can be using. All right. Okay. And I'm quickly gonna finish this. I see there's a couple of questions popping up in the chat. I'm gonna take care of them in a minute. And what I just wanted to show you here is how we insert one more row for the students. Some first row here, I'm inserting the student Alice, and the database system now gives me feedback. The first number that you see here, that one will be typically 0. That is only used if Postgres assigns so-called OIDs, but this is not going to be part of this lecture. The second number is more interesting. It tells us that one row has been inserted into the table. And here somebody is already proposing the correct command. Very good. Somebody is proposing a command to say, to essentially show the content of that table, which we will see in more detail later, but I can already give you the command here. We are doing select the star, which means we want to know something about all the columns from the students table, right? And now it shows me there's one single entry in the students table, right? So here I want to give you a little bit of a feeling for what it is like to use one of those database management systems. I should also say that this interface is, of course, very simplistic. Depending on which version, which tool, and which operating system you're using, you might have some nicer graphical interface, but the SQL commands, they remain the same. And I mean, in many cases, you would actually, in practice, you might not be using SQL directly, except if you are developing an application. Like in many cases, the end user is actually shielded from issuing SQL commands. you use some kind of interface which in the background generates SQL queries that are sent to some database. But of course, if you want to develop this interface, then you need to know about SQL. Okay, couple of questions. So, all right, so some questions already refer to advanced concepts, some of which we will not necessarily cover in this course, even though it's very interesting questions. Okay, here one question about the previous book exercise. So I quickly sketched out the solution, which uses 3 tables in analogy to the example that we did with students. Here the question is whether we couldn't have done it with 2 tables, like simply one table about books and one table about authors, and then have an array of book IDs in the authors table and have an array of author IDs in the books table. In principle, you can use arrays, but let's say the proper way, the most SQL way of doing things is that you, not sure whether I should formulate it that way, but for this course, we are only working with scenarios where we have single values, scalar values, single integers, strings, and so on in one field of your tables. But depending on which database management system you're using, there might be some advanced features that allow you to do things differently. Several new messages. Okay. One quick question about the first number in the insert statement. So that number is not relevant for this course. It basically, if Postgres would assign something called an object ID, then during the insert command, then this object ID would replace the 0 for this first of the 2 numbers. But since this didn't happen in this case, we have the 0 number. And for the purpose of this course, we will assume that one column and one row only has one single value, like one integer or one string. There's a couple of advanced features where you might not have it that way, depending on which system you're using. But for this course, one column and one row means you have one value. Okay. Good. All right. Good. So we are at the end of our time frame. I recommend you to have another look at the examples that we have seen. We had one in-class exercise, and until the next lecture, you might want to play a little bit with this example database and think about how you would insert or update specific books and authors in this database, and perhaps make one example where you insert data which doesn't comply with certain constraints, and so the database system might reject your updates. In the next lecture on Monday, we will continue seeing some more SQL features. We are going to essentially discuss about the interface to SQL first, and then afterwards, we will start discussing about how the database management system actually internally processes your SQL commands. The recording of this lecture will also be uploaded. If you have any questions, then the first point to turn to would be Piazza. All right. Good. Have a nice weekend, and then I see you on Monday.